welcome to this session. Thanks for joining us. Here, Riaan and I are going to provide an overview of the breadth of the ThingWorx platform, and along the way, we're going to highlight some of the things that are new in ThingWorx 8 as well. So it'll be a broad platform overview is what we're after here. ThingWorx is the leading industrial IoT platform. It's being used by partners and customers like yourselves to create countless solutions for smart connected products and smart connected operations in settings like factories, healthcare, oil and gas, and smart cities. Solution builders are choosing to use ThingWorx because of its industry-leading IoT capabilities as well as AR authoring and publishing tools. And these are the things that allow them to unlock the value in the convergence of the physical and digital worlds, as Jim discussed this morning.
So in this session, we're going to show you how to build the two examples that Mike highlighted in the launch session this morning. And we're joined on stage by Mike Wunderlich, who will be driving the demonstrations. So the first solution that we're going to look at is for smart connected operations, which is an application that is focused on the factory. Today's manufacturers are under intense pressure to deliver products on time, on cost, and with high quality. And meeting these goals, or meeting these demands, requires continuous effort to monitor and improve uptime, reliability, and efficiency to drive better productivity. So the ThingWorx platform makes it possible to build these role-based solutions, or role-based connected solutions, very rapidly, which includes the integration of disparate data sources of data, systems, and also the integration with machines and PLCs, frankly, without months of effort. The second example that we're going to look at, that Mike showed this morning, is a smart connected product solution. So all of us are using refrigerators, washing machines, and even light bulbs that are connected devices. This particular, this transformation is opening up opportunities for OEMs to tailor their services and their ability to design to, as well as to meet customer preferences. However, connecting all of these field-deployed devices, managing those devices, and then translating all of this information into business value is not trivial. And that is why we developed ThingWorx. So take, for example, this 3D printer. This 3D Systems is a new ThingWorx customer implementing the platform to improve printer servicing and to help their customers ensure the highest quality 3D prints. They see ThingWorx as the key to helping them develop more loyal customers and therefore to sell more units, therefore driving higher satisfaction with their customers.
So why do these customers see ThingWorx as so key? Well, ThingWorx is the market-leading technology for bridging physical and digital worlds because it provides the broadest set of capabilities. And these capabilities allow you to do things like source data. That is, incorporate and aggregate data from anywhere, wherever it is, directly from censored products, from systems, from PLCs and IoT gateways that are on the factory floor, and in this case on the stage, from existing product clouds, from your engineering systems where you have 3D CAD and configuration management in PLM, and from other business systems like CRM and ERP and others. Once you have that data, you need to be able to contextualize it. That is, structure it in a way that makes sense. The ThingWorx unified object-oriented thing model, which is at the heart of ThingWorx, enables you to do this. It enables you to organize the data from your physical products, from your systems, and structure that all in the digital world. And then enrich it with additional data, like 3D geometry, for example. And this is what essentially allows you to create a digital twin that you can leverage in all kinds of ways further on to drive value. Now, in order to maximize that value, you'll want to synthesize that data to gain insight. You need tools to easily analyze and simulate and predict physical product and system behaviors and their performance using included analytics tools that come with ThingWorx, as well as third-party deterministic simulation tools. Once you have insight into your products and systems and operations, you'll need to drive action. And we think about driving action in two different ways. One way is by orchestrating physical systems and digital systems. You need easy capabilities that integrate with and automate processes that affect and leverage business systems, products themselves, and physical operations. The other way to drive action is by engaging people to act and do something, to enable them to make better decisions and better perform their tasks by clearly presenting relevant, compelling information. Often today, through the web on the desktop or mobile apps, but more and more through augmented and virtual reality. So in our session here, we're going to use this schematic as a guide as we show you exactly how ThingWorx makes creating solutions fast and easy. And we're going to start at the beginning with sourcing data. In a smart connected operation scenario, we want to be able to monitor operational performance so that we can identify potential issues. To do so in a factory, for example, we would want to begin by getting data from lots of places, across various production lines, the machines on those lines, and across all kinds of end devices. We would need data from PLCs, from sensored equipment, from IoT gateways, like you see on the cabinet here, and very likely from cloud providers, as well as manufacturing-related systems like ERP and MES.
In fact, Mike, in our factory demo, we are interfacing with data from disparate, legacy, and third-party systems, as well as cloud-based IoT providers or platforms. Specifically, Azure, AWS. We're connecting to devices directly to the platform via our software development kits. We're connected to an on-premise manufacturing execution system. And lastly, we're leveraging industrial connectivity to connect to the PLCs. So working with both Azure IoT Hub and AWS IoT was trivial, as our productized integration provides a scalable integration with ThingWorx. This integration provides asset, model, and data synchronization, which provides the ultimate flexibility for deployments that rely on either AWS or Azure. And this is, of course, over and above our existing out-of-the-box edge capabilities. So to make it even simpler and easier for third-party integration, we have added an integration framework in ThingWorx 8, which supports Swagger.io, which is an industry-recognized framework that simplifies interacting with systems, like, for example, our PLM solution, Windchill. So that said, querying and showing raw data for an end user is not ideal. Instead, data and functionality that is relevant to the end user is typically organized for that end user, like, for example, a plant manager. And that particular plant manager can then drill down to see the relevant information for his or her role within the plant. For example, we may look at the data aggregated at the plant level. We may look at it at the line level. Or we may look at it within the scope of his or her job at a specific machine. In this example, we see a dashboard for the 3D printer that we have here on stage. As you can see, the printer is currently running low on material. And as we progress through this demo, you'll see how we use this information to trigger actions to avoid issues. And by doing so, we keep the line up and running.
OK, so sourcing data from all of these systems and from the assets themselves is the first step. But it's only part of the challenge. How do you organize it? How do you structure it? How do you make it meaningful for use in your solutions? That's where we come to contextualizing it. Only ThingWorx allows you to structure and enrich this data in a way that makes sense in the industrial IoT. To organize data from these physical assets, from your digital systems, which might include PLM, might include 3D CAD, and then enrich it with ThingWorx's IoT context, essentially creating the digital twin that will power your solution.
So we enable this through our IoT engine, which is expressed through what we refer to as our Thing model, and it's essential for developing these role-based IoT solutions quickly. This allows citizen developers to define static or dynamic data, to develop the business logic, and to then define the events and the subscriptions to those events within the context of the physical assets, like the 3D systems printer, and the digital systems. So let's show you what we mean by modeling a new asset on a factory line, in this case, a torque tool or a torque gun. For those of you familiar with ThingWorx, what we're seeing here is the new composer. We've updated the look and feel and improved the workflow to make it even faster to create these connected solutions. For this example, our torque gun is a factory floor asset that is connected via Kepware. And Kepware, as you may know, offers a library of more than 150 device drivers, client drivers, and advanced plugins, which supports thousands of devices and other data sources. With ThingWorx 8, we can easily source Kepware information, as any tags that are configured in Kepware are now automatically reflected into Composer. In fact, mapping and binding the data to our asset representation, which we call a thing within the thing model, is a simple process. To show this process, we configure the PLC tags in Kepware, and that data is, of course, shown in Composer for configuration. With just a couple clicks, we can map that data to our thing model. As you can now see, we can create what we call a thing, which will represent our torque gun. It's derived based on our industrial connectivity template. All of this is critically important from a developer's perspective, because the torque tool, once modeled in the thing model, is then reflected into an easily consumable REST API, which, frankly, we use for our application enablement tools, such as our Mashup Builder and ThingWorx Studio. But also, third-party applications can leverage this REST API to interact with the model.
OK, so in less time than it would take me to go make a cup of coffee, Mike has connected this torque gun here on the stage to ThingWorx. So I'm going to use the torque gun. And now that he's done that, the values, this torque gun is in fact a smart connected torque gun, and is streaming data off. And as I'm torquing the bolts on the cabinet here, what you'll see is that these values, the degree of each torque, is being represented up there in the dashboard. This data is streaming off the gun, through this gateway, up through Kepware, and into ThingWorx. Okay, so it's that easy to get the data into ThingWorx.
The thing model is, of course, not limited to just Kepware for connectivity. In fact, it's very common for us to create and model multiple asset types, and those devices can use different protocols. For example, emerging IoT standards, or in the case of what we've done with the 3D systems printer, we leverage our Edge SDK for bidirectional communication to the cloud. This particular model for the printer is clearly much more complex than the torque tool that we just looked at. And it has hundreds of properties, which again represent the static or dynamic data, as well as the services, which represents the business logic, and then the events, all of which represent the actual physical device, and subsequently the digital twin. So the flexibility and the ability to normalize data, services, and events across devices and systems dramatically simplify the process to create these role-based solutions.
OK, great. So we've seen how we can acquire data from a few different sources, and how easily we can get that data into the ThingWorx thing model. Now we can take advantage of this information, right? We can gain insight into these assets, into these operations, and drive behavior and outcomes. In order to gain that insight, we need to be able to synthesize this data. We need to be able to apply analytics and simulation to get the answers that we need. Now, building IoT solutions is actually a very analytics-intensive exercise. At the heart of every IoT solution is synthesized intelligence. Intelligence that helps us answer the hard questions about an organization, a product line, a process, or an operational unit. Now, this morning in the launch session, we showed you how easily you can detect anomalies and trigger alerts based on those anomalies. ThingWorx also provides easy-to-use tools to apply supervised machine learning to your data. And these capabilities allow you to answer questions like, what is happening, with visualizations that are purpose-built for IoT? Why it happened, by automatically identifying statistical patterns and relationships that affect performance. What will happen, by automatically creating and operationalizing predictive models that are based on historical data. And what should happen, with recommendations that optimize the likelihood of desired outcomes based on prescriptive simulations. Beyond that, ThingWorx apps can incorporate physics-based simulation and computational models from best-in-class tools like Creo, MathCAD, ANSYS, all of which will result in an even richer digital twin.
So using the historical observations of the outcomes that we want to predict, we can leverage a tool that we call Analytics Builder, which is an out-of-the-box tool to intuitively build and validate these machine learning models. Builder also provides the ability to explore exploratory insights to answer questions such as why something happened. In this case, we built a model by using the Analytics Builder to determine whether a printing job would complete successfully by using information about the printing job as well as the printer status. Some of the unique machine learning exploratory results, called profiles, are shown here. Profiles allow us to see distinct patterns within the data that lead to suboptimal performance. The output, and subsequently this visual, provides an intuitive description of the scenarios which occur in the data, which are otherwise obscured within the complexities of the model. Specifically, we can see the scenarios where our printers are most likely to fail. And in this particular scenario, we can just focus on, if we just focus on a specific range for the layers printed in the previous day, our probability of failure is 66%. But combined with a third-party printer head, a heating tray error, and a range of latitudes, the probability of failure increases to 87%. Once created, the predictive model provides the ability to understand what could happen or what should happen. Lastly, Builder allows us to publish this particular model to use within our applications. Another tool that we have is what we call Analytics Manager, which is used to operationalize these predictive models. This includes mapping data, deploying the model to the optimal location, such as the edge, and then leveraging data from the Thing model to calculate these predictions. As it relates to our 3D systems demo, we published various machine learning models from Builder, and we can then very quickly define how to execute and score these predictive models based on data changing and events firing within the digital twin in the Thing model. So in the cases where you have limited access to rich historical data, which frankly limits the ability to leverage supervised machine learning, we can also use Manager's open framework to generate data from engineering tools such as ANSYS or Creo. So including simulation into solutions basically provides the ability to create what we think of as virtual sensors. These help derive deep insights and predictive outputs in existing deployments where you may not have connected sensors. Virtual sensors also provide value in other areas, such as raising alerts and events based on future conditions, which may be caused by changes in operational conditions of the asset.
OK, so these analytics capabilities from Analytics Builder and Analytics Manager provide automation and maintainability for the intelligence that's embedded inside of your applications. Exposing and providing these types of outputs within a role-based solution to get this information to the right person at the right time is incredibly valuable, especially when you can do it with minimal effort, as Mike showed. Now, our Smart Connected product app shows some of these outputs on the landing page. Here we're looking at here we're including the aggregated results showing KPIs, such as the predicted percentage of printers that may run into issues. Showing this data with clear state-based formatting allows for the end user to quickly focus on assets that require his or her attention. Now, ThingWorx delivers a wide variety of approaches to generate insight using both deductive and inductive learning. And this includes making it simple to include outputs from partner tools or from custom models that might be built by your data scientists. Now that we have this data-driven intelligence, the next question is, how do we drive action? How do we drive results, both in our physical assets, the printer, as well as in our digital systems? How do we automate the processes that connect our business system data, our physical products, and our operations? In other words, how do we orchestrate? So if you're a system admin in the audience, I'm sure you'll agree that orchestrating processes across just one enterprise-level system, think about CRM or ERP, can be challenging. And when we think about the industrial Internet of Things, with many disparate systems, lots of different sources of data, connected assets in the factory, connected products in the field, that challenge grows exponentially. Solving these challenges is what ThingWorx is built for. It has utilities that are designed specifically for managing and orchestrating across devices, across processes, and across your business systems. So let's take a look.
So returning to our example solution, we have set up a workflow to take action when our 3D printer is running low on material, or when it may run low on material based on the predictive model that we just reviewed in Synthesize. Proactively taking action is a great way to avoid downtime and improve efficiency for any device. So an important aspect of the ThingWorx workflow is the fact that each step in the process is based on the Thing model. For example, we can leverage the material level property to indicate when a step should be taken to start a new material order requisition. Additionally, things like software updates or actions can occur as a result of a workflow request, perhaps from the OEM's environment, or perhaps based on an engineering department updating the firmware and needing to deliver an update, or perhaps based on the device itself requesting an update based on the bidirectional communication after local configuration by the operator.
So this is a great example of how easy it is to orchestrate processes across the systems and the devices. But what about us? How can we easily make data and insights accessible and enable people to make smarter decisions and execute informed actions? Well, ThingWorx provides a broad range of capabilities to allow people to engage with the connected assets, to engage with the connected systems, and to use all of this rich, insightful information so that they can do their jobs faster, they can do their jobs better, and they can make better decisions in their day-to-day work. These capabilities enable connected solution builders to clearly present relevant, compelling information, as well as bidirectional interfaces in whatever form factor makes the most sense, through the web on the desktop, on a mobile app on your phone, as well as with augmented reality experiences.
And these experiences are incredibly easy to use, or capabilities are incredibly easy to use. So here's the application for the printer that we've been working on. And Mike, let's take a look at how it was created. Apps like this are built in a very easy-to-use drag-and-drop environment that we call the ThingWorx Mashup Builder. This provides a means to intelligently leverage all of the data and the business logic from the Thing model to quickly create HTML5 solutions. It's got a palette on the left. It's got a canvas in the middle representing the application. And then on the right, we're exposing all of the richness of the Thing model. So in order to add more data or to take action within an application, we simply drag and drop a widget, we bind it to the data or the services from the Thing model, we format it, and then we're done. So Mike has added a temperature stream, and here we can see how it looks like in the fleet management app.
There it is in the lower right-hand corner. OK, that's the widget that he just added. So people can engage with the rich data the rich data, devices, and operations connected to ThingWorx in other ways as well. So that was a great example if I happen to be the printer OEM or somebody that's servicing the printer. That's the kind of information that I would like to see. But what's it like if I'm the operator of the printer? And what's it like if I'm standing right next to the printer? In those cases, that's where the power of augmented reality and IoT combined really shine. Now, this morning, I showed you that ThingWorx includes game-changing technology called ThingWorx Studio. ThingWorx Studio is purpose-built to allow you to easily create augmented reality experiences. It enables you to quickly and easily expose all of the IoT data, all of the richness of the Thing model through augmented dashboards, as well as to present augmented work instructions by easily reusing existing 3D assets, CAD data that you likely already have. And best of all, it works without requiring you to write any code. Now, some of you are familiar with augmented reality, and you've tried to do these kinds of things in the past. With ThingWorx Studio, you can expect that what might have taken you weeks with other tools will now take minutes. That's the kind of productivity that we're trying to deliver with ThingWorx. Riaan, let's take a look at it in action.
So this is ThingWorx Studio. Studio is very similar to the Mashup Builder in that it has widgets on the left, it has access to the Thing model on the right, and it also has a canvas in the middle, but in this case, it's 3D. It enables you to drag and drop 3D geometry and other 3D components, as well as 2D mobile components to create these augmented reality experiences. Those experiences can be published to the cloud or to an on-premise deployment of ThingWorx, and just like the Mashup Builder, it's easy to use. So we've got an experience that we've partially built for this 3D printer, and it includes a virtual gauge. And we can associate the value from the physical device to the gauge by just binding it to the Thing model. A new capability in ThingWorx 8 is the ability to actually bind commands to the 3D object or items in the experience so that a user can just click on the 3D itself. Let's add a step-by-step sequence to the door of the printer to show that how to replace materials when they're low. Keep in mind that Studio also allows you to author information in both 3D as well as 2D. We've improved the 2D capabilities in ThingWorx as well, and now it's very easy to create table-driven dashboards. So we'll use the new grid widget to lay out such a table that will represent all of the data from all of the printers in a 2D view. And over and above this, there's many other improvements in Studio, like the ability to invoke pop-ups in AR based on perhaps alerts from the Thing model. But in the interest of time, let's just publish this and then take a look.
OK, so once the experience has been published, all experiences that are created in ThingWorx Studio can be viewed in ThingWorx View. ThingWorx View is an app available in the App Store for iOS, for Android, for Windows 10 tablets, and also for the HoloLens, as we showed this morning. Here, we're going to use an example with an iPad. And what we're seeing is Riaan's iPad displayed on the screens to the side. And you can imagine that he was a line manager who was walking the floor of the factory. And at a glance, he'd be able to review the status of all of his 3D printing equipment in this tabular view. This is the grid that Mike laid out in Studio. Now, one of the printers requires his attention. You can see that clearly, because it's low on printing material. And it shows up in red in the list thanks to another improvement in Studio, which in ThingWorx 8 Studio, that conditionally formats data in an experience based on the values in the Thing model. So when it's below a certain level, it's red. When it's below a higher level, it's yellow. And when it's above that, it's simply presented in white. Now, as he approaches the printer with the issue and then selects it in the list, the dashboard switches to an AR experience. In this experience, he sees the content that Mike just added, digitally overlaid as context in his view of the physical printer. And you can see that there's not enough material to complete the job. So this is an example of the pop-up that Riaan mentioned as well. You can see the virtual gauge showing the current amount of material remaining. And again, this is driven directly from the sensor in the printer going up to ThingWorx, directly connected to ThingWorx, and then presented in the AR experience. And he also sees data from another business system, our queuing system. The queuing system is showing him that clearly the next printing job will not complete unless he replenishes the material right now. Okay, how to do that? Well, he can select directly on the door. So you'll see in the camera shot, he's picking with his finger on the 3D geometry in the view, and then he can see clear, intuitive instructions on how to remove and replace the material cartridge. So rather than spending time finding the manual and reading it and interpreting it, he can simply select on the drawer in the experience and see what he needs to do. It's clear, it's compelling, it's engaging, it's incredibly cool. And with no need to translate the text-based instructions, it's easy for anyone around the world, regardless of the language that they speak, to get this job done.
So let's recap what you've seen today. We've shown you ThingWorx's ability to source data from anywhere. The demo that we showed you received data from AWS IoT, Azure IoT Hub. We had an integration into an on-premise manufacturing execution system. We also access data from the printer directly through our Edge software development kit. And lastly, we source data from the torque gun through ThingWorx industrial connectivity powered by Kepware. To learn more about how to get data into ThingWorx, you'll want to join Jeff Bates and Rob Black in their session tomorrow, or on Thursday, excuse me.
So we also showed you how to contextualize this data, how to capture it in the ThingWorx Thing model, where you can develop business logic, define events, and subscriptions within the context of the assets and the systems so that it can all be reflected in an easily consumable REST API for you to use as you build your solutions downstream. We showed you how easy it was to build the Thing model for the torque gun from scratch, coming in from Kepware, and then we also showed you the example for the 3D printer. The Thing model is the fastest and easiest way to scale an IoT solution to the hundreds of thousands of devices without complex programming. And if you want to learn more about this, Rob Black has a session tomorrow. You should join that.
We also showed you how to synthesize this data to gain insight into what is happening, why it is happening, and how to predict what will happen in the future. We showed you how to easily detect anomalies in data streams, how to use Analytics Builder and Manager to, frankly, predict and then operationalize the likelihood of a successful print job. To see more of the breadth of the analytics capabilities in ThingWorx, as well as how to incorporate physics-based simulations from ANSYS, join Mark Williford and Dave Magnoni in these sessions.
And then we used that insight to orchestrate a workflow. We kicked off a new material requisition based on the material left in the printer, and we also orchestrated a software update which kept the firmware on the printer up to date. If you want to learn more about the utilities in ThingWorx for orchestrating, as we showed here, and also how to deal with software and content management, you don't want to miss Ken Rawlings' session tomorrow.
And finally, we showed you how to engage people with web-based applications built in the Mashup Builder, as well as with augmented reality experiences built in ThingWorx Studio. You've got to try out all of these experiences for yourself in Extropolis. And to learn more about the outstanding tools for people to engage with ThingWorx, you'll want to join Mark Schutz tomorrow morning.
So these folks that we've mentioned are just a few of the members of the world-class PTC team that's here at LiveWorx. We're all dedicated to bringing you the very best industrial IoT platform. In closing, I want to recognize some of the award-winning PTC partners that are building on ThingWorx and helping our customers achieve amazing results like some of the examples we've shown here. We really appreciate these partnerships, and we couldn't succeed without them. And then finally, a huge thank you to 3D Systems who loaned us the printer. We're looking forward to their success with ThingWorx as they deliver even better solutions for their customers.
And finally, we thank all of you for joining this afternoon. Enjoy the rest of the event.
Thanks so much.
Thanks.